Hi, welcome to N8.4, multiplying fractions, including mixed numbers. So, lots of things that you need to know about fractions before you can do this outcome. So I've included a couple of those things on this list, describing real-life fractions situations, how to reduce a fraction, and this is very important when you're multiplying because you can reduce before you even multiply so that you're working with smaller numbers, a little bit easier. Reducing your fraction in the end so that you end up with an answer that's lowest terms, converting mixed to improper and improper to mixed, and knowing how to divide fractions by flipping the second fraction, turning it into a reciprocal, and then multiplying. Comparing fractions to whole numbers and decimals, estimating your answer, so knowing if you've got something that's reasonable or not. And it's interesting to note that multiplying doesn't always give you a bigger answer, especially when you're working with fractions, and dividing may not always give you a smaller answer. You're like, what? This is so backwards to everything I've ever learned. I know. Just go with it. It's all good. Using an array, so that same little strategy that we learned back in grade 5 where you're putting everything into a box and splitting it up into parts, you can use that for multiplying fractions. Solving word problems, and perhaps drawing a picture to represent your fraction. Let's see what we got here. All right, general multiplication of fractions. So this one's pretty easy. 2 over 4 times 2 over 4. So all you're going to do when you multiply a fraction is multiply the top by the top, multiply the bottom by the bottom, reduce. In this case, they didn't do any reducing before they started. They just multiplied the top by the top, multiply the bottom by the bottom. They got 4 over 16. Make sense? Now, this answer isn't in lowest terms, so they're going to have to reduce. So when you're reducing, you know that you're dividing. What you do to the top, you must do to the bottom. So if I'm going to divide by 4 on the top, I need to divide by 4 on the bottom, I end up with a quarter. But I want to show you a little trick, because there's an easier way to do this. If they would have reduced these fractions first, they wouldn't have had to do the reducing in the end. So 2 quarters can be reduced to 1/2, right? Divide by 2, 1/2. So 1/2 times 1/2. Now multiply straight across, top by the top, that's 1, bottom by the bottom, that's 4, which is exactly what we got doing it the other way. It's just a little bit easier if you can reduce first. Kind of cool. So another example of reducing first, you can reduce something on the top and something on the bottom when you're multiplying only, not when you're adding and subtracting. But when you're multiplying fractions, that 7 and that 3, they're going to end up combined as a 21 anyways, and the 6 and the 9 would end up combined anyways. So you can reduce something over here on the top with something over here on the bottom. So they've said, hey, the 3 and the 6 have a relationship. Those two are kind of related. I could reduce those two before I even start. So they've said, let's divide the top by 3. And what you do to the top, you must do to the bottom. So also dividing by 3. They crossed out the 3 and they turned it into a 1. So now our fraction is 1 over 9 instead of 3 over 9. So smaller numbers, a little bit easier to work with. And we end up with 7 over 2. So 7 over 2 times 1 over 9. Okay, so now we end up with 7/18. We don't need to reduce at the end because everything was done beforehand. There are a few different ways that you can convert an improper fraction or convert a mixed fraction to an improper fraction. So mixed is when you have a whole number and a fraction, like 1 2/3, and improper is what they end up with on the other side there, 5/3. Improper means the top is bigger, the numerator is bigger than the denominator. So let's just draw a quick little picture of this. 1 2/3, I'm going to draw a chocolate bar, it's red, don't judge me. And I'm going to draw that same chocolate bar. Okay. So the 1 would mean that we have all 3/3 of our chocolate bar filled in, and the 2/3 would mean that we only have 2 of those thirds. So you could represent a number like 1 as a fraction it could be 3/3 if you wanted it to be. And it's easy then to see that 3/3 plus the 2/3 gives you a total of 5/3, which is what they converted to. So if you don't feel like drawing a picture or you can't do that in your head, there's a way mathematically to do it. And so that's explained in the brackets there. You want to take your whole number and multiply it by your denominator. Essentially, that's giving you that 3/3 thing that we were just talking about. So you're thinking 1 times 3 is 3, so you've multiplied, swoop down and multiply the bottom, and then you're going to add the top, add those extras, and that gives you a total of 5, and then you keep the original denominator. So multiply the whole number by the denominator, add the top, presto, it's converted to an improper fraction. So 2 ways that you can do that. Multiplying a fraction, once you've got it converted, you don't want to use a mixed fraction when you're doing multiplying or dividing. It's just too hard. So you need to convert whatever you're using in your equation, you need to convert to improper if necessary. And that will make it easier for the multiplying and dividing to happen. Multiply, you just multiply straight across. This one says reduce if possible. So in this case, these two numbers have a relationship, right? And so 4/5 times 1/2. That 4 and that 2 can be reduced. I can divide by 2 right there and call that a 2, and divide by 2 there, and that becomes a 1. And so 2 times 1 is 2, and 5 times 1 is 5, 2/5. Now, if you look at it really closely, you're multiplying something by 1/1, which is just 1. So obviously what you had over here, the 2/5, it doesn't change. It equals 2/5. And the next tip here, before you start to multiply two fractions, you can save time and make the problem easier by reducing if possible. So let's say you had 5/10 times 4/12. 5/10 can be reduced to 1/2, and 4/12 can be reduced to 1/3. So sometimes you can reduce just that fraction. Okay. And then you're multiplying with a lot easier numbers. And so they just did the example from the top there. Notice they didn't reduce at the bottom. They did 4/5 times 1/2. They didn't do all the fancy stuff that we did up there. So they ended up with 4/10. But that's not in lowest terms. So now you have to go back, divide by 2, divide by 2. What you do to the top, you must do to the bottom. And then you end up with 2/5. So it's kind of cool if you can reduce first before you do your multiplying. All right, dividing. A little bit harder because there's one extra step. You have to choose the second fraction and flip it over, create a reciprocal. Do not touch the first fraction, only the second one. All right, so in your question of 3/10 divided by 1/2, this is the guy we're flipping, right? The second fraction. Do not touch the first fraction. So 1/2 becomes 2/1. That's what happened when we flipped it into the reciprocal, and now we're going to multiply. So step 1, flip, step 2, multiply. Which one are we flipping? Okay, so 3/10 times 2/1, and you can look real close and see that, oh, there's some relationships. I could cancel some stuff out. I'm going to divide by 2, that becomes 1, divide by 2, that becomes 5, and then I don't have to do step 3. So if you reduce first, then you don't have to reduce at the end. And if you're not cool with reducing first, that's fine. It just means an extra step in the end. So 3 times 2 is 6, 10 times 1 is 10. They ended up with 6/10, and then they reduced and got the 3/5 anyway. So, all right, estimating fractions and with multiplying and dividing to see if you're getting a reasonable answer, and understanding that multiplying doesn't always result in a larger answer and that division doesn't always result in a smaller answer. So let's say I have my chocolate bar and I have it divided into fifths. I don't know why, I've got a real chocolate bar theme going on this year. Always be a good Christmas present for me. Just saying. Okay, so my fifths of my chocolate bar, I'm going to divide those fifths up into thirds. Okay, so I want 1/3 of 1/5 of my chocolate bar. Now we know, there's my third, we know what of means, right? Of means multiply. So 1/3 times 1/5. So I'm multiplying, and all your life you've been told that multiplying is going to give you a bigger answer. Not so when you're using fractions. It might not. And so in this case, I'm getting a portion of that 1/5. So 1 times 1 is 1. 3 times 5 is 15. We're just multiplying. Multiply straight across. Multiply straight across. I'm getting 1/15 of a chocolate bar. That shouldn't be very many calories, right? And same with division, because division is the same thing, except you're doing that reciprocal deal. If I'm going to take half of the chocolate bar and divide it by a quarter, that means I'm taking a half of the chocolate bar and multiplying it by 4/1. Okay, so I can reduce top and bottom here. I see a relationship. Divide by 2 is 2, divide by 2 is 1. I end up with 2/1, which is 2. So if I'm going to take a half of the chocolate bar and split that up into even pieces of 4, that means I have a half and a half and a half and a half. Essentially 2 whole chocolate bars. So it's kind of weird with multiplying and dividing fractions. You might not get a bigger answer. You just have to be aware of that. So happy multiplying.